Hey, this is Horner, and this is the Friction Lab. So I just want to kind of show you how this works. When you first load this up, there's a lot of things you can do. You can change the surfaces, so rubber on ice. Here we've got aluminum on steel, glass on glass, graphite on graphite, and wood on the lab table, and that's the one that I want you to start with. You can increase and decrease the object's mass. So go ahead and knock that all the way down to the bottom, so it's about 100 grams. At this point, you're going to hit start, and when you hit start, it's going to sit. This force is going to continue and increase until, boom, that block should start moving to the right at a constant velocity. So what does that do? Well, when that happens, you're going to end up with a graph. Now, notice this graph is really different looking. So here we've got it's kind of a slope, but you'll see all these dots from where all the data has been taken, and then suddenly, boom, you'll see that it gets knocked down and comes down here. So there's a reason for that, and this lab is all about friction. So one of the first things that we need to do is let's draw a free body diagram for this block. So when the block is sitting on the table, we know that straight down we're going to have mg, and then straight up we have the normal force. So there is our free body diagram, and just the forces up and down. When you are pulling it to the right, that is a force of tension. And then to the left, there is a force of friction. But you'll notice that it sat there for a while, and then it started to move. So as this tension got bigger, then the force of friction was a certain type. So anytime anything is just sitting still, we say that that thing is static, S-T-A-T-I-C. And the friction that is holding it so it's not going anywhere is called the force of static friction. So we're just going to put F, little f, and then put an S. And that S means static. Then when that block is moving, there's also friction, but that friction is what we call kinetic friction. So kinetic like the word movement, and the abbreviation for kinetic friction is FFK. And so these are the two different types of friction. So friction that holds something on a hill. So for example, if you had a ramp and you put a block on the ramp and that block doesn't go anywhere, it's static friction that's holding it there. And then if you lift it even higher, so let's say that we lift it up to here, and then that block starts to move down the ramp, so it just keeps moving down, then now we're dealing with kinetic friction. So those are the two different types. One of the things that we need to do is we need to just talk about the equation for this. So the equation for friction is the force of friction, and whether it's static or kinetic, is equal to, so let's go ahead and do kinetic friction first. So that's equal to mu k. So this is the Greek letter mu, mu, and this just tells how sticky something is, or how much friction it could have. So S-T-I-C-K-Y. For example, if I had sandpaper, sandpaper has a really high coefficient of friction. It is, probably somewhere around about 0.9. On the other hand, ice, which is very slick, has a coefficient of friction about 0.01. So notice that they're vastly different. If I have a coefficient of friction of 0.9, then when I drag something to the right, it's kind of hard to do, and it's got a lot of friction. So my force of friction would be really high. On the other hand, if I'm pulling this across ice, it's going to have a very low value. So there's one more thing that we need here, and that is the normal force. And so we know the normal force is Fn. For the lab that you're doing, remember this is straight down, this is mg, and then straight up we know we have the normal force. So let's do the sum of the forces, and let's think about that in the y direction. So up and down. It's not really moving at all in the y direction, so we're going to say that's equal to 0. We know that if we say up is positive, then the normal force minus mg is going to be equal to 0. And if that's true, then the normal force is exactly equal to mg. It's just in a different direction. So whatever value we get for mg, we're also going to use that for Fn. So notice that the mass of the object is 1,000 grams, but we can't use this gram. We've got to go back. We need to divide this by 1,000, and remember there's 1,000 grams in every kilogram. So if we divide the two, we're going to end up with 0.1 grams. But if I want mg, so here's my mass, I'm going to multiply times gravity, which is 10 meters per second squared. And if I do that math, I'm going to end up with a force of 1 Newton. So my mg is 1 Newton, which means that Fn is 1 Newton. So this Fn, for what we're doing right here, is worth 1 Newton. The other equation for friction is on your AP Physics 1 equation sheet. So I'm going to switch to it really quick here, maybe. Maybe not. And so if I switch over to it, maybe not, then this is equal to, so the force of friction that is static is always less than or equal to mu, but this time instead of k, we're going to put mu s since it's static friction, times the normal force. Now everybody wants to know, why is it that this is less than or equal to? Well, it's because if you notice at the very beginning of this, so let's go back, at the very beginning of this, if I reset it, you'll see that when we start this simulation, time is running and it doesn't move. So in that region right there, that's static friction. So that friction is less than or equal to the force pulling onto it. When it's equal to it, it doesn't move, but then when that force gets just a little bit more and it hits that same coefficient, it starts to move. So we're going to reset it and we'll get it to go here, and boom, it starts to move. So you'll see kind of that force that gets it to go. So that is the difference between static friction and kinetic friction, and I think we can go to the equation sheet now. Here is the equation. So notice the force of friction is less than or equal to mu times Fn, where mu is that coefficient of friction. So this would be for static. For kinetic, you would just make it equal. So that's the difference between the two. How do you do the lab? That's the next question. So we've got the two surfaces are wood, so it's a wood block and it's on the lab table, which is that kind of slick black material. And the data table that we're going to fill out is over here. So let's go ahead. We have reset it. Let's start it again. And when we start it, it's going to make a graph down below. So you'll notice that this graph looks a little bit different. I'm going to reset it one more time and start it again, and you'll notice that as time goes on, this line here, this sloped line, continues to get bigger until the block moves. So let's do it one more time. Here we go. You're going to see the line come up, and then when the block moves, boom, this drops back down. And it drops down because the static friction is always going to be bigger than whatever your kinetic friction is. So your maximum static friction is going to be bigger than your kinetic. The force over here is actually representative of the force of friction. So we know that this force is really the force of friction. The very top dot, so we can see that that dot is about right here, has a value of 0.8 newtons. So this is going to be the force of friction, and because the block doesn't move up to this point, we're going to say that that is static friction, and the value here is about 0.8. So let's go ahead and put some numbers in right here. And the very first number that we're going to put in is going to be the mass, and we said that the mass was 100 grams. We divided by 1,000 to get 0.1 kilograms, and then we multiplied by 10 to get the weight. So that is 1 now. The normal force and the weight, remember these two things are the same. So mg and n are the same, so that's 1. And then we just said that the static friction force was this very top value, which is approximately 0.8. And so we'll go ahead and put that in. The kinetic friction force is going to be this lower line, and it's just the average value. So notice at the bottom of this is this is 0.5 here, so this would be 0.56, and then 0.62. So right in between the two, we're going to get somewhere around about 0.58. So our kinetic friction force here is about 0.58 newtons. So we're going to do this again. We're going to say reset. We're going to go back up, and we're going to increase the mass. Notice that when you increase the mass, you're going to jump up to a different number probably each time. So that makes it so that you and the person that is doing this next to you or at your table, you're all going to have slightly different values, and then that way we know that you've all done the lab. So I'm going to bump it up to the next value. It's 181 grams. So I'll go ahead and put that in, find the mass in kilograms, find the weight, then I'll run it, and I will look at the data down on the bottom. So that's essentially how you're going to take data and kind of some of the things that are introduced in terms of friction. So the one last thing you're going to do is when you're done, you're going to make a graph. And that graph is going to be over here. So you'll have a graph, and that graph will be the friction force. So this is the friction force, and let's say we do static friction first. Down on the bottom, we're going to have the normal force, and you will get a straight line. So if you don't, your data is really messed up, but you'll get a straight line. You'll have your points here, so it'll do the best fit, and then it'll give you a value. So let's say that this value is somewhere around 0.05, okay? The unit for that, notice this is in newtons. This is also in newtons, so there's no unit for your slope. So there is no, oops, it's not working, there we go. There is no unit for the slope, and that's just not coming out, so we'll just act like it did. The equation, remember we said, was the force of friction is equal to, and then we said it was mu times the normal force. So when we graph it, remember this is your y-axis, this will be your slope, and then this, so slope is m, this is your x values. And so that should help a little bit as you go through. Our slope is going to then tell us what the coefficient of friction is. And that is just the basics of how to do the lab.